Je suis Anna Inés Ansaldo, chercheur au centre de recherche de l'Institut universitaire de gériatrie de Montréal. J'ai vraiment un grand plaisir aujourd'hui de vous présenter professeur Vittorio Galesse. Professeur Vittorio Galesse est professeur de psychobiologie à l'Université de Parma, en Italie. Il a été professeur d'esthétique expérimentale à l'Université de Londres. Et il est ici aujourd'hui grâce à une collaboration entre le CRIUGM et le partenariat Cinex Media, qui est co-dirigé par Santiago Hidalgo et André Gaudreau, ici présent. Donc, on est très heureux. C'est une première et non pas la dernière. Donc, professeur Galesse est un expert en neurophysiologie, neurosciences cognitives, neurosciences sociales et philosophie de l'esprit. Il est un des découvreurs aussi des neurones miroirs. Ses recherches tentent d'élucider l'organisation fonctionnelle des mécanismes cérébraux sous-jacents à la cognition sociale, notamment la compréhension de l'action, l'empathie, le langage, la lecture, la théorie de l'esprit et l'expérience esthétique. Nous sommes vraiment très heureux, professeur Galesse, que vous soyez ici aujourd'hui. Je vous laisse la parole.
Good morning, everyone. Thank you so much, Ines, for your nice introduction. And thank you for inviting me. It's a privilege and an honor to talk in front of this cross-disciplinary audience. Cross-disciplinarity has been always been a sort of target in my work, and I congratulate for the big accomplishment that you achieved here in Montreal. And I also apologize for giving my talk in English, but if I had given it in French, you would hardly regret. So be happy with this. Okay, so I'm going to go quickly through this point. I will start with a sort of epistemological overture, which means when we deal with the issue, how do we understand others? And we want to approach this question with the toolkits of neuroscience. What are we aiming? So the neuroscience of what exactly? Then I will briefly introduce the mirror mechanism and my model of embodied simulation to get to some preliminary conclusion on all these fascinating topics. Okay, let me start with the destructive part of my talk. This is something I've been challenging in the last 30 years. The metaphor of the sandwich is not mine. It's from a late philosopher, Susan Hurley, which coined. It looks a bit like a caricature, but not so much. Why a sandwich? Well, in any sandwich, the most interesting part is in the middle. And in this particular sandwich, the important part is cognition. And as you see, perception and action are peripheral to cognition. Second element, there are two distinct realms. So if we translate that in brain anatomy, the part of the brain which deals with action is separated from the part which deals of perception. Third wrong element, all these three modules, so to speak, are connected by a unidirectional flow of information. According to this model, through the senses, you associate them, you build a perceptual representation of reality, which is fed as an input to your cognitive apparatus, which elaborates, manipulating symbols, and eventually the motor system kicks in only when you decide to translate this cognitive deliberation into movement. To put it in a nutshell, this model is false. The brain doesn't work like that. Second model I want to challenge is the so-called Swiss Army knife idea of the mind, according to which, in the course of evolution, our brain incorporated different modules, each of those in charge of dealing with specific skills that were adaptive to adapt to the ever-changing environmental situation that push the brain and the body to adapt to coming up with new models. I don't have time to get into the details, but when you claim modularity, you must stick to a definition of module. One of the earliest to propose this architecture of the mind was the philosopher Jerry Fodor, who published a very famous book in 1983, I think, The Modular Mind. So you can use the notion of modularity as freely as you want. If you are speaking of module, at the very least, you must imply that what's going on in the module has to be encapsulated. If you translate that in brain architecture, it means that if you suppose there is a module in charge of understanding others, mind reading others, the so-called TOM, theory of mind module, that implies that if this can be translated in a specific location in the brain, and many people hold this view, it implies that the neurons sitting there have to deal only with mind reading, but the same applies for language and other cognitive skills. My idea is completely different. My idea is that since our brain was not designed by an engineer, but is the result of multiple adaptation to changing situation in the world, operates in different cognitive domains by means of reuse, which means that part of the brain that were selected and evolved to support a given function can be reused when the evolutionary pressure force the brain to come up with something, the brain and the body. I don't buy the brain in a vat. So when I refer to the brain, it's always brain-body, okay? So if I occasionally mention the brain, I always refer to a brain wired to a body, which is in relation to the world. Okay. So we are told that there is a mind reading module, which is basically composed of a posterior hub, which is TPJ, the temporal parietal junction. All these colored dots are the result of a meta-analysis showing that this part of the brain systematically is activated when people are engaged in mind reading, like attributing false belief to others. Another hot spot in the so-called theory of mind module is the ventromedial prefrontal cortex. Same reason why these two hubs are considered to be specific for mind reading. Only mind reading is occurring there. If you talk to many people who support this view, one name out of many, Rebecca Sachs, who is in Harvard University. We had many exchanges in public confrontation, and she's positive, and she published many papers where supposedly she shows that this area is only activated when mind reading is at stake. But there are many problems with this view, and not coincidentally, I point all these problems with a phrenological head, okay? In 100 years, when people will look at this debate, I think we'll laugh as we laugh at the poor phrenologists that try to localize in different parts of the brain by inspecting the skull, moral, aspiring, anima, reflectiveness, perceptive, love for your country, and everybody laughs. Well, I think what we are facing as we speak is a neo-phrenology, is a 2.0 phrenology, but we could do much better than the poor Gohl and Spurzheim, because they didn't have all the expensive toolkits that we have, that we can employ to ask questions to the brain body. So we should do much better than this. So the first problem I see with this still mainstream view is that we do not have a clear neuroscientific model of how humans can understand the mental state of others. What we have is a series of brain imaging studies showing the activation of a set of cortical regions, like the one I show you, during explicit mentalizing tasks. However, no one to date was able to provide a convincing explanation about why those specific areas do activate during mentalization, beside the, let me phrase it like this, tautological statement that mind reading is implemented in those brain areas. So it's a kind of circular way of reasoning. A further problem, the mind-reading specificity of the activation of this cortical region is debatable, if not patently false. I would say it's patently false. There's plenty of evidence that these areas, TPJ and the ventromedial prefrontal cortex, can be activated in a variety of tasks that have nothing to do with mind reading. Please understand me well. I'm not saying that it is coincidental that all these areas systematically activate when we attribute mental state for others, but we don't know the reason why. And there must be a common denominator which makes these areas activating when we attribute mental state to others, but also in other tasks which have nothing to do with mental state attribution. And the common denominator, in my opinion, is the body, particularly when you have to disentangle who is who. But suppose that this mainstream view is correct. Suppose that in order to mind read, these brain areas are necessary and sufficient. The first serious attempt to understand how the brain works was accomplished by clinical neuropsychology. I was trained at the Institute of Physiology by my mentor, Giacomo Rizzolatti, at the very beginning when I was a sophomore in the School of Medicine, but an intern in the Institute of Physiology with the historical text of clinical neuropsychology, Luria, Danny Brown, and the like, because that was the first serious attempt to establish a relationship between brain function and cognitive function or sensory motor skills. So if, like in this particular case, we have a massive bilateral lesion of the frontal pole of the so-called theory of mind module, like this lady, who, because of an infarct, has a bilateral destruction, as you can easily see, comparing just the color of the brain in this anterior part, which is totally destroyed. We would expect, it is legitimate to expect that this patient has problems in attributing mental state to others. Unfortunately, for this theory, and luckily for us, this is not the case. This is a paper published in Brain in 2004. Among the authors, Uta Fried, who has been one of the supporters of this theory, where they say GT, the initial of the patient, as a dysexecutive syndrome, not surprisingly, characterized by impairments in planning, memory, as well as a tendency to confabulate. Importantly, however, she did not have any significant impairment on task probing her ability to construct a theory of mind, demonstrating that the extensive medial frontal regions destroyed by her stroke are not necessary for this function. We concluded our findings urge caution against using functional imaging as the sole method of establishing cognitive neuroanatomy. Very clear. Then what? Well, I've been proposing already a few years ago that all kinds of interpersonal relations depend at the basic level. This is not all there is in intersubjectivity, but I'm a bottom-up guy. So by school, by tradition, I like to start from the bottom. So we reach the roof starting from the basement and not the other way around, deriving the basement from the roof. And so starting from the basement, interpersonal relation, in my opinion, at the basic level, depend on the constitution of a shared manifold space. And this shared space is functionally characterized by, from a functional point of view, embodied simulation routines. So I think it makes little sense to look for a one-to-one mapping between concepts, words, employed to describe social cognition and their supposed location in the brain. This is why I'm speaking of a neophrenology. Neuroscience deals with all these levels at the subpersonal level. Psychology and philosophy deal at the personal level, but neuroscience deals with neurons, brain circuits, brain areas, the brain. Subpersonal, because all these entities that we study are one component of the holistic whole, which is the individual, the subject, the self, the person. We came up with different words to describe this whole, okay? So our goal is to understand the whole, the individual, by describing subpersonal levels like neurons, neurotransmission, cortical integration, and the like. So I think that this level of description is necessary. Otherwise, I would have changed my profession. I'm still happy to be a cognitive neuroscientist, but not sufficient to understand social cognition. In order to understand social cognition, we need more ingredients. We need to study the brain in relation to the body, the relationship between the brain body and the world, and notably with the brain body of others, okay? So without the demonstration of a specific correlation between brain states and mind states, and ideally of their causal relationship, there are ways to establish a causal relationship. One is clinical neuropsychology. The other is transcranial magnetic stimulation, where you can either excite or reversibly inhibit part of the brain and observe what follows the excitation or the reversible inactivation. Most of what we are dealing with on our daily practice as experimentalists is correlation. And we are happy already when we can demonstrate that our correlation is specific and significant. So without the demonstration of a correlation between brain state and mind states, much of contemporary brain imaging approach to social cognition, as I said, look like a sort of high-tech version of phrenology. So I think we should do much better than that. We should investigate the putative functional antecedents of our cognitive skills, first of all, by adopting a comparative perspective, which is exactly what I did in my career. For the first 20 years of my career, I recorded single neurons in behaving rhesus macaques. Then I moved to the human brain. We are part of an evolutionary continuum. There are no gaps. There are syntax or stuff like that. So the comparative perspective is very useful because it enables to see how much we have kept from our antecedents, our evolutionary predecessor, and this liberate the table from things that we share with other animals so that we are able to focus on what we rightly or wrongly consider uniquely human. So a comparative approach and also measuring, this is also very important, the sociocultural influence exerted by human cultural evolution onto those very same cognitive skills. I'm a very convinced supporter of the biocultural paradigm. We have been taught for ages that we should keep separate Naturwissenschaften and Geistwissenschaften. So the scientific study of nature and the scientific study of culture has been moving on two parallel and paths that do not communicate. Culture is an expression of our nature. Technology is an expression of our nature, okay? So this is very important because when you speak many times with people from the humanities, we are dealing with culture. What has culture possibly to do with the brain? And I think this is basically wrong. And at the same time, many people in my community, they say, why are you talking to philosophers? Why are you talking to art historians? I mean, what is all about? Neuroscience in the long run will provide all the answer. I think this is crap. We need to collaborate because we all asking the same question: who we are, how do we function in the world, why we created culture, why we created art. This is something really specific of our species, symbolic expression, and these are very complicated issues which require a cross-disciplinary approach, which you are pursuing, and I, in my little lab, since many years, I try to push forward. So in this way, we can analyze some of the concepts we normally use when referring to social cognition, determining their constitutive elements. Ideally, that's the goal, with a subpersonal level of description, will be able to better understand or even revise some of these concepts that we normally employ in philosophy, in psychology, in aesthetics, to talk about ourselves. So cognitive neuroscience should investigate human nature first and foremost by clarifying what human experience is made of. And this is also something which is not mainstream in neuroscience as we speak. Cognitive neuroscience pursue a line of research which is, in my opinion, too logocentric, which identifies thought with the language of thoughts, namely with language, which is more concerned in the way we explain the world rather than understanding the way we experience the world. So my major concern is experience, what experience is made of. And so a few years ago, I wrote a paper in a collection of essays where I invited the neuroscientific community to phenomenologize itself. What does it mean to phenomenologize cognitive neuroscience? It means to start neuroscientific research from the analysis of subjective experience and about the role that the living body plays in the constitution of our experience of material objects and of other living individuals. So let me move now on the intercorporeal side of intersubjectivity, which I repeat it again, my claim is not that all there is in social cognition is a bunch of mirror neurons firing in my head. There's a lot more than that. But we should not start from the top. We should start from the basic level. I think human beings, even at the pre-linguistic stage of their development, they have a rich social cognition, which employs other instruments than the language. The language has not taken over yet, but they are richly communicating with their adult peers, with their mother, with their fathers, and with other individuals in their own social environment. And the key player in this story is not language, is the body. Let me introduce mirror neurons. Okay, let me start like this. There's a lot of crap about mirror neurons. I was telling Andre 2 days ago, I got a Google alert when everything is being published about mirror neurons everywhere. And guess where? This was referring to an article appeared in L'Osservatore Romano, which is the newspaper of the Pope, of the Vatican in Rome. The headline was, Jesus Mirror Neurons. And you can find everything like, oh, now we know why we are good people, why we are altruistic, because we have mirror neurons. And I could continue with a lot of crap. So all this hype about mirror neurons was very detrimental for us because people tend to believe that this crap comes from us, which isn't true, of course. But anyway, I think this discovery was important because for the first time revealed a subpersonal level of description that can connect people, okay? We have not only empathy, which is a philosophical or psychological tool, but we found neurophysiological subpersonal evidence showing that our brain and the brain of many other animals is wired in such a way where the connection with the other is fundamental, and this probably was an incredible evolutionary process to develop a mechanism that could directly link one another. So here we are, this is zooming in the ventral premotor cortex of the macaque monkey. This area F5 is where we coincidentally discovered the properties of this neuron that we later on denominated mirror neurons. One distinctive feature that drove our research, actually there were two. First, the motor system doesn't deal exclusively with movements. The motor system deals with goals. So goals is a cognitive notion, is the outcome we expect from a given movement. I want to grasp this object. In order to grasp this object, I need to organize the motor output in such a way that can accomplish the goal, taking possession of this object. Traditionally, the motor system is cognitively dumb, which means it deals with movement. Cognition, the goal, is being dealt somewhere else. And there is this funny idea that the more anterior you move in the brain, the more cognitive it gets, which I always found really bizarre. Once at the meeting, a colleague told me, oh, wait a minute, if it's motor, it can be cognitive. And if it's cognitive, it can be motor. And you're laughing, but most people still believe it like that, okay? So this neuron control the goal to be accomplished, like manipulating object, taking hold of object. But this, and this is the second discovery being made in Parma, well before mirror neurons, not only that these motor neurons are goal-related, but they are multisensory. So they respond also to perceptual input. So for example, the very same neuron that control my grasping of this object will be activated also when I look at the object, even if I have no purpose to grasping it. When I look at this object is not only a perceptual target of my visual system, but it's also a potential goal for my motor system. And we were studying neurons that control the grasping, but also respond to the observation of the object. So it's a motor potentiality. It's a motor simulation. So in order to clinically test the neuron before submitting the macaque to a more quantitative test with the turntable, with objects, very complicated task, I have not time to describe, we were grasping objects and presenting them to the monkey, and we were expecting a response, a visual response at the moment of the visual presentation. But we noticed that some of these neurons were firing, they were activated, we were listening to the noise through the amplifier. But the most exciting part of my career was asking questions to the brain, listening to the response through the loudspeaker, the spike of the neuron. There's nothing compared to that profession. And so we realized that the neurons were not firing when we presented the object, but when we were grasping the object. I said, wait a minute. So the same neuron that fired when the monkey grasped is also responding when I grasp. And at the beginning, we thought it was an artifact. So it took us months to record the EMG of the hand, of the mouth, to make sure that what we were measuring was not a motor response, but a genuine visual response. When we realized that what we were observing was a new finding, a new property of the motor system, we got really excited, very much, because from the very beginning, to be honest, we had the vision that this could change the field. And indeed, social neuroscience practically didn't exist before the discovery. Nobody spoke about empathy. It was a monadic neuroscience. After mirror neurons, it became at least a dyadic one. Okay, so the property of this neuron is that they not only fire when the goal is accomplished motorically by the monkey, the second discharge, but also when the monkey is doing nothing but watching one of us performing or another monkey performing the same action. So we were interested to learn more about this brain circuit. So in Parma, we have this unique collaboration between functional neuroanatomists and who were formerly physiologists and physiologists. So our colleagues inject a neural tracer in the part of the brain where we recorded for the first time mirror neurons. We discovered that this part of the brain is part of bidirectional network connecting posterior parietal areas with ventral premotor areas. We went into those parietal areas, we recorded news from them, we discovered mirror properties also there. And to make a long story short, we were able through the years to demonstrate that this neuron discharge when the action is executed or observed, discharge when the action can only be imagined for cues. So suppose I show you this object, then I hide it behind the screen. You see my hand disappearing. You don't expect my hand to come up with a rabbit, but with a wrist watch. So you are imagining what your visual system cannot reconstruct. Mirror neurons can do that. They discharge when the action consequence can only be heard. So if you break a peanut out of sight of the monkey, the very same neuron that fires when the monkey breaks the peanut or see someone breaking the peanut will respond also to the noise being produced by someone breaking the peanut. So if you put all these properties together, we are dealing here with an abstract motor mapping of action in a species which is 25 million years before the invention of human language. So the idea is that this mechanism underpins a non-meta-representational form of action recognition. Then many other labs started investigating the properties of mirror neurons. This is one example for our colleagues in Tübingen, in Germany, and this is very important also for cinema, because this experiment contrasted the response of mirror neurons when the monkey is observing a living human being performing the action in front of her, the naturalistic action, but also a digitized version of the action projected on a bidimensional computer screen. The vast majority of mirror neurons respond to both. Neuron 1 exemplifies one half of the neuron that prefer the naturalistic action. The orange curve represents the response of this particular neuron when watching the naturalistic action. The black curve, the response of the same neuron when the action is played back on a bidimensional screen. But the response is highly significant in both cases. The remaining half, no difference. The intensity of the response is the same. Monkeys do not movie theater in the jungle. So what does this mean? It means that detecting, recognizing the action of someone else is so crucial for primates that this mechanism is able to translate its own functional mechanism also to a technological translation of the action in a bidimensional medium like a computer screen. But it tells us something more, which has very deep implication for the times we are living in. It means that the way our brain treats reality, the naturalistic action, or a representation, like in the case of the film action, is not categorical, is dimensional. So if we build a technology that makes it possible to build a parallel world which looks like the real world, our brain will follow and will be living in a fake world. So think about AI. This is a very hot topic. Montreal, luckily enough, is leading a battle which I see very problematic, but that has to be fought. But anyway, that's a different issue. So this mechanism is also able to project this motor potentiality even to map apparently abstract motions like these balls that move, however, with a biological kinematic. So the possibility of the mechanism is also to map apparently abstract content by using the body as the reference framework, so to speak. But how the brain disentangle between who's the agent and who's the observer if we have a mechanism that responds to both? Well, both at the single neuron level and at the population level, as in this graph, mirror neurons tend to respond with a higher intensity when the action is executed with respect to when the action is observed. So they likely contribute also to agents' implicit sense of being the authors, owners of their action. So the motor system, in my reading of these properties, provides at the same time the common ground and the distinguishing criterion for the bodily awareness of one's own and others' actions. This is a review paper we published a few months ago, just to celebrate the 30th anniversary of the discovery in Trends in Cognitive Sciences. It's open source, so you can freely download it. And as you see, along the years, many researchers in many labs in the world discovered similar properties in other animals, in birds, in rodents, bats, rats, mice, macaque, where we discovered, and humans. And it also became clear after an hypothesis I put forward 23 years ago, together with the philosopher Alvin Goldman, that mirror neurons for action could be the tip of a much bigger iceberg. namely that similar mechanisms could be found also in the domain of emotion and sensation, which turned out to be the case. So in this paper, we summarize these first 30 years of research in the following way. The findings reviewed here suggest that the most evolutionarily shared and original function of mirror circuits is an active one, because they evolved primarily to enable the readout of social interactions, promote vicarious learning, and facilitate the planning of behavioral responses to others. What about humans? Well, for many years, we had to fight the challenge that these mechanisms didn't exist. There were colleagues, one name for all, Alfonso Caramazza in Harvard University, who even published a paper and convoked a press release to say, we proved that mirror neurons do not exist. Unluckily for him, a few months later, with the same paradigm, Chris Fritt and colleagues at University College London, with the very same paradigm, by the way, obtained opposite results. But finally, at UCLA, the group of the neurosurgeon Isaac Fried, which at the time was the unique group making single neuron recording for the human brain, came up with the final proved evidence that even at the level of single neuron, you can spot this mechanism in the human brain. So now we don't have to waste our time to say, yeah, they do exist, but we can focus on what they are for, what is their function. So to make a long story short, in the domain of action, these are parts of our brain that turn out to be active during the observation, the execution, and the imagination of a variety of movement, symbolic action, transitive action, and the like. So through the activation of the mirror mechanism, we can recognize others' basic action, so to speak, from within. This is clearly not the only way to make sense of others' behavior, but it's the most basic one, and it has a specific phenomenal quality, where this is not explaining, but understanding in the first place. Understanding, so it's the same difference that in German they would draw between erklären and verstehen. This is verstehen. So it's Einfühlung. I use part of my brain-body apparatus to understand what you're doing, what you're planning, what you're feeling, what you're experiencing. So thanks to the mirror mechanism, we can recognize in what we perceive motor outcomes and basic motor intentions without necessarily relying on propositional inferential reasoning, which is clearly something that we do all the time, but it's not the only game in town. That's my point. Perhaps at this basic level, we have motor inferences. So the mirror mechanism, of course, is not able to provide us with the reason underlying motor intention. Why am I grasping this wristwatch can be determined by a variety of reasons. Just to check if it still works, how am I doing with time in my talk? So this is clearly out of the possibility, heuristic possibility of the mirror mechanism. We need to have coming into play other brain circuits whose, however, neurophysiological mechanisms, I'm sorry for our colleagues in cognitivism, are yet to be understood. So motor cognition. This is one of the neuroscientists I'm more indebted with, one of the smartest people I ever met in my career. Unfortunately, he's not among us anymore. Is Marc Jeanneret, one of the first in Europe to establish an Institute of Cognitive Neuroscience, where he pulled together neuroscientists, psychologists, philosopher of mind, anthropologists. He was really a visionary, a pioneer, a highly cultivated person, closely related to Paul Ricoeur. I mean, I could continue. I was fascinated by him. He was a gentleman. I mean, I'm missing him a lot. In this book, which I highly recommend to you, Motor Cognition, 2006, he wrote, motor simulation can thus be proposed as an explanation for the embodiment of action representations and their grounding in the neurosubstrate. The core of the explanation is that the simulation mechanism is comprised of a set of rules which are embedded in the neural substrate of the action representations. So the cortical motor system is not merely a muscle control, but an integral part of our cognitive system. So that's why the sandwich model doesn't work. It is actively engaged with the processing of spaces, environments, objects, actions, gestures, and static scenes. Motor outcomes and motor intention are part of the vocabulary being spoken metaphorically by the motor system. Often we do not explicitly ascribe motor intention to others, we simply detect them. I posit that motor mapping is enough to ground the directness of a motor act to its outcome. So the functional architecture of the cortical motor system not only structures and controls our actions, but also plays a crucial role in the way we perceive, imitate, and imagine the movement and actions of others. When acting or imitating someone's action, the corticospinal pathway is activated, causing the excitation of muscles and prompting the ensuing movements. When instead we observe someone else or imagine movements and action, execution is inhibited. The motor system, however, is still activated, but not in all of its parts and not with the same intensity as when we actively move our body. I'm defining this as one particular instantiation of embodied simulation. Action is not produced, but only simulated. But embodied simulation is bigger than mirroring motor actions, than motor resonance. It encompasses the activation of somatosensory, touch-related areas during the observation of others' tactile experiences, the activation of pain-related areas like the anterior insula or the anterior cingulate cortex during the observation of others' pain, the activation of the anterior insula and the amygdala during the observation of others' emotion like disgust and fear. And we were the openers of this research. We were the first to ask ourselves this question, test them empirically, and prove them empirically. So embodied simulation maps the sensory aspects of the action, emotion, or sensation of another onto the perceiver's own motor, visceromotor, or somatosensory neural mapping of that action, emotion, or sensation. And this mapping, in my hypothesis, enables the experiential feeling to the observed action, emotion, or sensation of others. I mean, I can learn by mere cognitive association that when I see someone with a corner of the mouth going up, that symbolizes happiness, while if they go down, it means he's sad. But that doesn't tell me anything about how does it feel to be happy or how does it feel to be sad, which is the role of empathy, of Einfühlung, feeling in the other. And this is something that embodied simulation, in my hypothesis, can accomplish and make possible for us. This is an experiment done at Niguarda Hospital by a former PhD student of mine, Fausto Caruana. These are epileptic patients waiting to undergo the surgery to remove the epileptogenetic disease part of their brain. Drug therapy doesn't work. The only solution is neurosurgery. But of course, you want to take away only the disease part of the brain and leave untouched the healthy part. So they implant this electrode that enable you to record and stimulate. By stimulating a restricted portion of the anterior cingulate cortex, you can evoke laughter and mirth in this patient. This patient all of a sudden start laughing, and then the surgeon asks, "Why are you laughing? What are you laughing at?" I said, "Well, I don't know. I mean, I feel elated, I feel mirth, I feel happy, and I can't refrain from laughing. There's nothing I can do to stop it." One patient, she even said, "I tried to resist. I thought when I lost my dog, but I couldn't help by starting laughing." Okay. With the same electrode, you can record from the same brain location that you see that tiny little yellow dot is where if you stimulate, you attain laughter. If you record, you attain a response only when the patient is seeing someone laughing. The first picture to the left. If you see someone crying or making meaningless grimaces, there's no response, okay? So emotional experiences such as mirth and merriment can be evoked by stimulating frontal areas traditionally deemed to control motor output, including this that I just showed you, the pregenual anterior cingulate cortex, the supplementary motor area, and the inferior frontal gyrus. So the neural systems supporting emotional production and experience largely overlap, diffusing the experience expression dualism and nullifying the need for serial processing in the emotional brain. Some scholars advise that emotional responses follow the emotional experiences in line with the early suggestions by Darwin. Some others run the serial processing in the opposite direction, considering emotional responses to be the trigger of the emotional experience. Following James, I weep, therefore I'm sad, okay? We propose to abandon this dichotomous interpretation, retracing the original criticisms that two of the other Fab Four of American pragmatism, so there are four, right? James, Dewey, Mead, and Peirce. Both Dewey and Mead moved against both Darwin's and James' perspective. Agency is a core feature of emotional experience, and its behavioral expression is part of the ontology of some emotion. Okay, I'm almost done. Embodied simulation aims to explain the mirror mechanism, and related phenomena like vision of manipulable objects, mental imagery, the representation of peripersonal space, all issues I couldn't, of course, you can understand in 50 minutes, address in my talk, the representation of peripersonal space and various aspects of language. That's another long topic. Because of reuse of given mapping formats, we map the actions of others onto our own motor neural maps, as well as others' emotion and sensation onto our own visceral motor and sensory motor neural maps. Embodied simulation theory provides a unitary account of basic aspects of social cognition. Of course, it's not a whole story, but it's where we start from, for sure, holding that people reuse their own mental states or processes mapped with a bodily format in functionally attributing them to others without explicitly putting yourself in the mental shoes of the others, like the traditional theory of simulation a la Alvin Goldman would maintain. The bodily format instantiated by neural mapping constrains what such neural mechanisms can map because of the bodily constraints posed by the specific configuration of the human body, which in turn constrain the way it interacts with the world. We can jump, we can sit, we can stand, we cannot fly, okay? So this constraint dictated by the physical relationship we entertain with the physical world, which shape our evolution as bodies, has a major influence in determining how the brain machine is mapping the bodily relation to the world. By neural reuse, different brain areas participate in different functions through their dynamical engagement with different brain circuits. This is not me, this is Michael Anderson, who is London, Ontario. A given cognitive function can be supported by a variety of brain circuits, and according to his theory, the newer, in evolutionary term, a cognitive function is, the wider the brain circuits underpinning it. But there are no neurons in the brain with a t-shirt with written, I'm dealing with syntax, I'm dealing with morphology, I'm dealing with semantics. Neurons deal with action potentials, with electricity. These are words. So the tricky issue is to connect this level of description without committing the fallacy of attributing to neurons the level of description we normally use when we deal with the personal level of description, which is really difficult, believe me. And if you ask me, I have much more confused ideas now than I had 20 years ago. Emotion is a mess, the field of emotion. I had much clearer idea on what emotions are really about. And why so? Because we know more. And the more we know, the more we appreciate the complexity of the mechanism. So in a way, the more we know, the less we are aware of what we know. Or better, the more we are aware of what little we know, okay? Not many people would admit that. They are very proud in their neurohubris because we have a machine worth $1 million, and so we can somehow explain everything. I wish it was true, but clearly it isn't. So the human body plays a constitutive role in foundational aspect of social cognition. The body is the a priori, non-further reducible condition of possibility of experience. This is one of the few things I'm that certain about. And if this is true, it follows that intercorporeality is the ground level of intersubjectivity. Action, perception, and cognition at the level of the brain-body largely overlap. The intentional character, the aboutness of what we call the mind, which in my opinion doesn't exist. There are mental processes, the mind is a word, is deeply rooted in the intrinsic relational character of the bodily neural format of the mapping of action, in turn constrained by specific body-world relations. And I want to conclude to limit the relevance of the metaphor of mirroring, because this can be highly misleading. What is a mirror? Is a physical surface which reflects only and exclusively exactly what you put in front of it, unless it is a deformed mirror. But if it's a proper mirror and you put an apple in front of the mirror, the reflection you get back is that of an apple, not of a pear, of a peach, or whatever. We are different. If we want to pursue the metaphor of mirroring, we should add a crucial ingredient. We are metabolizing mirrors. So we mirror, in a way, who we are. And who we are is the historical accumulation of experience, which in turn literally shape the way our brain reacts to our relation to the world. So I want to conclude with one of my favorite Italian writers, Primo Levi, who in this collection of short novels, and this short novel is beautiful, it's entitled The Mirror Maker, writes, what does a mirror do? It reflects, like the human mind, but normal mirrors obey a simple, inexorable physical law. They reflect like a mind that is rigid and obsessed, that claims to grasp the truth about the world, as if there were only one. Thank you.